Hi, welcome to the Olympiad geometry. Let's continue our study of Simson's theorem. Here is the problem. A, B, C, D is cyclic. The feet are perpendicular from D to the line AB, BC, CA are P, Q, R respectively. Show that the angle bisectors of ABC and CDA meet on the line AC if and only if PR equals to RQ. This is a problem from IMO 44, which is the year 2003. So we will see that this problem is not a difficult problem if you know the Simson theorem. So let's just read the problem again. That we have A, B, C, D, which is quadrilateral, cyclic quadrilateral, and from D we do perpendicular on each line A, B, B, C, and AC. We find the foot that P, Q, R. So we know that P, Q, R are collinear based on the Simson theorem, right? So we know that P, Q, R are collinear. So let's say we find that RP equals to RQ. We know this. Now we want to prove that the angle bisector of angle ABC and angle bisector of angle ADC meet on the line AC, right? So on AC we find one point. If we connect that, that's the angle bisector for both angle ABC and ADC. For the angle bisector, the only thing we know about, or the only theorem we can think of, in a triangle is that we know ABC. So if this is AD is angle bisector, then we know that AB divided by, the ratio of AB to AC equals to the ratio of BD to DC, right? That's the only theorem we can think of. Which means in here, if we can prove based on the condition RP equals to RQ, we can find that AB to BC equals to, if we can find AB to BC equals to AD to DC, that means the angle bisector of angle ABC and angle bisector of angle ADC meet on the line AC, right? So basically we want to find if this is true, if this equation is true, when we have the condition RP equals to RQ. So what we can find from RP equals to RQ, right? We want to find some ratio, which means that we need to take the advantage of RP equals to RQ. We want to put the RP to RQ as a ratio, right? So RP equals to RQ. So let's just do RP divided by RQ, right? RP divided by RQ. And then we know that because PRQ are collinear and ARC are collinear. So in the triangle PBQ, right? In the triangle PBQ, if we use a line ARC to intersect this triangle, then we can use a many layer theorem that PR to RQ times QC to BC, right? Times BA to AP equals to 1. This is true based on the Mendeley's theorem. And we know that PR to RP to RQ equals to 1, which means QC to BC times BA to AP equals to 1, right? And because in triangle APD and the triangle CQD, right? If we look at these two triangles, the triangle APD and triangle CQD, they are all right triangle, and the angle DAP equals to angle QCD, right? Because ABCD is a cyclic quadrilateral, so the angle PAD equals to angle DCQ, which means triangle APD is similar to triangle CQD, which means QC to AP equals to QC to AP equals to QD to QP equals to QD to DP, right? Equals to DC to DA, right? So we have QC to AP here. We can replace it to DC to DA, which means DC to DA times BA divided by BC equals to 1. Right. And this, look at here, we can rewritten it as AB to BC equals to AD to DC. Right. Because this ratio, the AB to BC ratio, it equals to the angle bisector connection points. Let's say it's E, that's CE to EA. For the AB to BC, that's AE to EC, and AD to DC, that's also AE to EC, right? So that means the angle bisector line are meet on AC. And you can think that all of these steps, we can move it back, right? We can all, they are all, so if AB to BC equals to AD to DC, which means we already have the line, the angle bisector line meet on the AC point, this is valid, so this is valid, which means we can put it back to here, right? Force this to be valid, right? Because this has to be valid because of the Mendeley's theorem, and all of these are valid, which means this equals to 1, so that RP to RQ equals to 1, which means RP equals to RQ, right? That means the this condition and RP equals to RQ. All of these are valid. So this is a problem of IMO in 2003. I think this is one of the simplest problem I've seen in the IMO. Basically, it's difficult to find such easy ones in nowadays IMO, but I hope you like this video. It's just take the use Simson's line theorem and use Mendeley's theorem. Just use two theorems to solve the problem. Okay. See you in next one. Thank you.